A simple harmonic oscillator consisting of a mass m attached to a spring with spring constant k. When it is in motion at the surface of Earth, its period is t. The same spring is attached to a mass of m and moved to a location r above the surface of the Earth, where r is the radius of the Earth. Calculate the new period. Now we write our period equation for mass spring system. T equals 2 pi square root of m over k. Now T new becomes 2 pi square root of 2m over k. So the location r did not show up in the equation. So it simplifies to 2 pi square root of m over k times square root of 2. Now the first term, 2 pi times square root of m over k, has a name, which is the old period, t. Then it simplifies to t times square root of 2. And this is our answer for the problem. Now, if the problem is not mass spring system, but instead it is a pendulum problem, note that changing the location of the pendulum does affect the period of its oscillation. The period equation for pendulum system, t equals 2 pi square root of g over l. The new period, t equals 2 pi square root of g nu over l. Now we need to calculate g nu, because this is a new location and g is going to change at this location. G equals capital G, universal constant, times the mass of the planet over r square. Nu g equals capital G times the mass of the planet, now it is 2m, over the radius square, but the radius is now 2r square. And we simplify this in terms of old g over 2. So now we can use this result, nu g, plugging into our period equation to calculate new period, t new. And that simplifies to t over, in terms of old period, over square root of 2. This is a new period for a pendulum system.